This is section 8D, passing a list. You'll often find that it's useful to pass a list to a function, whether it's a list of names, numbers, or more complex objects such as dictionaries. When you pass a list to a function, the function gets direct access to the contents of the list. Let's use functions to make working with lists a little bit more efficient. Say we have a list of users and we want to print a greeting to each one of the users. The following example sends a list of names to a function called greetUsers, which greets each person in the list individually. We define greetUsers so it expects the list of names, which it stores in the parameter names. Right here is the parameter names. The function loops through the list it receives and prints a greeting to each user. Here's the greeting. Here, we define a list of users, and here's the list, and pass the list usernames to greetUsers in this function call. And the result will be, hello, Hannah, with a capital H, hello, Ty, with a capital H, and hello, Margot, with a capital H. That's the output we wanted. Every user will see a personalized greeting, and you can call the function anytime you would want to greet a specific set of users throughout your program. When you pass a list to a function, the function can modify the list. Any changes made to the list inside the function's body are permanent, allowing you to work efficiently even when you're dealing with large amounts of data. Remember, a list could contain millions of items. Consider a company that creates 3D printed models of designs that users submit. Designs that need to be printed are stored in a list, and after being printed, they're moved to a separate list. The following code does this without using functions. The program starts with a list of designs that need to be printed and an empty list called completed models that each design will be moved to after it has been printed. As long as designs remain in unprinted designs, while unprinted designs right here, the while loop simulates printing each design by removing a design from the end of the list, pop right here, storing it in current design, append current design, and displaying a message that the current design is being printed. It then adds the design to the list of completed models. So here's that print statement. When the loop is finished running, a list of the designs that have been printed are made right here. We can reorganize this code by writing two functions, each of which does a specific job. Most of the code won't actually change, we're just making it a little bit more efficient. The first function will handle printing the designs, and the second will summarize the prints that have been made. At 1, we define the function printModels with two parameters, a list of designs that need to be printed and a list of completed models. Given these two lists, the function simulates printing each design by emptying the list of unprinted designs and filling up the list of completed models. So here's the doc string, and here's a loop popping unprinted design, printing current design, which is the popped one, and appending current design to completed models. Here's the second function where we define the function show completed models and have the parameter completed models. And so you can print each item in completed models using this function. So with all of that defined at the beginning of our code, as we're running through our program, all we have to do is have our list of unprinted designs and our list of completed models, which is empty at the beginning, but eventually it could have some things in it, and call print models, passing both lists, and then call show completed models after that first function, and it will have all the completed models in that list. This program has the same output as the version without functions, but the code is much more organized. The code that does most of the work has been moved to two separate functions, which makes the main part of the program easier to understand. Look at the body of the program to see how much easier it is to understand what the program is doing. And here's the body of the program. We've set up a list of unprinted designs and an empty list that will hold the completed models. Because we've already defined the functions, all we have to do is call them and pass them to the right arguments. We call print models and pass it to the two lists it needs. As expected, print models simulates printing the designs. Then we call show completed models and pass it the list of completed models so it can report the models that have been printed. The description function names allow users to read this code and understand it even without comments. Of course, you would use comments here because we always expect things to be read by idiots. But it would be pretty efficient to be using this with a company, and said idiots would be able to at least understand this part of the code. This program is easier to extend and maintain than the version without functions. If we need to print more designs later on, we can simply call print models again. If we realize the printing code needs to be modified, we can change the code once, and our changes will take place everywhere the function is called. Say, for example, if that printing code actually included a statement where we literally sent it to the printer, and then we got a new printer. We could simply change it right there in the function and wouldn't need to make those changes every time we printed. This example also demonstrates the idea that every function should have one specific job. So if you look back at the function, of course, we could have made one function that does two things. However, it's best practice to have one function for each thing that you need to do. This way, if you need to reuse just part of the function, you can because it's already in two functions, so you can just reuse that one thing instead of having to do both things or having to recreate a function. And you can always call a function from within another function, so it's most helpful to keep your function down to one kind of action per function, one purpose per function, and then just add functions if you need more purposes. Sometimes you'll want to prevent a function from modifying a list. Let's say you started with a list of unprinted designs and wrote a function to move them to the list of completed models, like in the last example. You might decide that even though you've printed all the designs, you want to keep the original list of unprinted designs for your records. That would be really important, say, if a client decided to get angry with you. But because you moved all the design names out of unprinted designs, the list is now empty. And the empty list is the only version you have. The original is gone. So if the printer screwed up, you don't know what needed printed. In this case, you can address the issue by passing the function a copy of the list and not the original. Any changes the function makes to the list will only affect the copy, and the original list would stay intact. You can send a copy of a list to a function like this. Note the colon right here in brackets. This is slice notation, which makes a copy of the list. It sends the whole list as a copy to the function. If we didn't want to empty the list of unprinted designs, we could call print models like this. Here's using it in that specific function call. So here's what the actual arguments look like. And notice we don't have to use a slice notation for both of them. I want the function to modify completed models because it's empty and it's going to have stuff added to it. So I wouldn't want to make a copy of it. So the function is happy because it gets its two lists, and we're happy because unprinted designs doesn't get changed, so I can still preserve the contents of that list. Even though you can preserve the contents of a list by passing a copy of it to the function, you should pass the original list unless you have a specific reason to pass a copy. It's more efficient for a function to work with an existing list to avoid using the time and memory needed to make a separate copy, especially when you're working with large lists. You will not notice a difference in the list that we're using of 5 or 10 people. But if you were running a list, for example, for a really large 3D printing company, you actually would experience some lag time while it made the copy of the list, and you don't ever want to create inefficiencies in your programs like that if you can avoid them. Here's some assignments for you, because that is the end of 8D.